City, France, who is going to speak on storm types across India, definition, characteristics, and predictability. So,
hello, thank you. Do you hear me?
Yeah, you are hearing.
Okay, I will share my screen. So everybody look at that?
Yeah, it's okay.
Okay, thank you very much. So I will thank the organizing committee for giving me the opportunity to share my work. So as everybody knows, it's difficult to predict the Indian rainfall as any tropical rainfall due to the multi-scale interaction between different processes. And usually we use a time average or filtered quantity to predict, to try to enhance the signal to noise ratio and to emphasize any quasi-periodic feature in the rainfall fields. But this approach has at least three different issues. The fact is, it may be insufficient to filter out the impact of very extreme local scale events, which are rather frequent across India. It can blur the predictability outside the wettest period, because when we look at the seasonal rainfall, of course, we can blur what is happening during the onset or during the end stage of the monsoon. And the last issue is the fact that there is no clear relationship between the bandwidth of rainfall variation across India. So my point today will to present you a different complementary approach, where I will start from the wet event, that is the local scale rainfall determined from only records of rainfall from 64 stations. So just to set the scene of predictability of India, as you know, and as we know from the 2 days presentation, there are some opportunity for forecast across India, which are the strong role of a low pressure system, which are large scale phenomenon, and also the role of the intraseasonal oscillation, which is also rather strong across India. But one feature could blur the predictability, which is the mean intensity, which is quite high across India. It is one of the tropical area where the intensity of rainfall is the largest across the land area. So as I said before, I will start from the wet event. So the wet event, it's very trivial to define. It is just the consecutive wet hour defined from a threshold of 0.1 millimeter per hour. So I use 64 stations across India from 69 to 2016. And I got almost 300,000 wet events. So we can use many features of the wet event as the duration, the total rainfall, the mean intensity, that is only mean rain, and the maximum intensity. So here you have the distribution of the wet event with the black line, which is the distribution of the wet event themselves. The red line, it is a wet hour, and the blue line is the total amount due to the wet event versus the duration. As you can see, most of the wet events are very short. They last less or equal than 5 hours, 90%. And this short wet event represent 70% of the total wet hours and 60% of the total rainfall. And then we clustered this wet event just based on the wet event itself. So I just use a normalization of the square root of hourly rainfall to just remove of the bias due to the skewed distribution. And thus the cluster is defined only from the duration and Hooly intensity at local scale. So I will present you a clustering in 6 classes, and I will refer to the 6 classes to storm types. So here you have the distribution of the Hooly rainfall across the 64 stations together. So you have the Hooly rainfall in the y-abscissas in millimeter, and the duration from the start, which is the first hour, in the x-axis. So as you can see, the first 2 storm type 1 and 2 are very weak and short. That is, the rainfall stay very weak, especially for the first storm type. Then we have 2 families of storm types. The first one, storm type 3 and storm type 5. You see that the rainfall could be very intense during the first 2 hours of the storm event. But these events are quite short, and usually they last far less than 4 hours. And then the second family, storm type 4 and storm type 6 on the right, you have longer events. They last more than 5 hours in general. They provide more rainfall in total, but the mean intensity could be lower than for storm type 3 and storm type 5. Here are details of storm type 1. So in red, you have the distribution of the storm type, and in black line, you have all the wet events. And you can see that, for example, this storm type is very frequent. It's 61 of all wet events, but it's very short and it does not provide a lot of rainfall. If you look at storm type 3, you can see that it is still quite short. 76% lasts less than 2 hours or equal to 2 hours. But you have here very intense rainfall during this hour. And you can see on the right panel on the bottom that it is strongly phase-locked with the diurnal cycle. So we can assume that this storm type is mostly due to the diurnal convection and perhaps related with isolated thunderstorms. And then we go to the fewest storm type. It is very rare, only 1.3% of all wet events. It's storm type 6. It is the longest wet event far from the other. And you see that they provide a lot of rainfall, but they are less intense in mean than for storm type 6. And you can see that the rainfall are less phase-locked with the diurnal cycle in the bottom left, right panel, excuse me, with the blue line. So we can assume that this storm type may be related with a large-scale event like a low-pressure system or large mesoscale system. So when we look at the 6 storm types, so the first row, it is the duration. The second row, it's the mean intensity. The third row, it is the maximum intensity. And the last row, it is the phase of the start of this wet event. We can see that storm type 5 is close to storm type 3, but it is longer and it still include very intense rainfall and quite phase-locked with the diurnal cycle. Storm type 4 is close to storm type 6, but it is shorter and slightly less intense. And storm type 2, it is a mixing between storm type 1, very short and weak rainfall, and storm type 4. When we relate the storm type to the scale of the event, so here you have the comparison of the distribution, of the storm type in color, with the area of the total rainfall received in the emerge dataset. So you can see that storm type 3 and 5 are far smaller than storm type 4 and storm type 6. And the largest events are the longer events. So there is a link between the size, the area of rainfall, and the duration of the local scale event. Here I tried to relate the occurrence of storm type with the OLR dataset. So you have 3 columns. The first, it is the full anomaly. The second, it is the intraseasonal anomaly. And the last one, it is the synoptic anomaly. So it's for storm type 4 and storm type 6, which is the largest and the longer wet event. And as you can see, it is well related with the main ISO component, that is a northward propagating wave, the second column. And you see also a connection with the synoptic timescale of the last column, which could be related with low pressure system traveling in mean from southeast to northwest, excuse me. When we look at storm type 3 and storm type 5, we have still this signal, but the anomaly are weaker than from the previous storm type style. So it means that we have a phase looking with the main intraseasonal and synoptic timescale. But in this case, the connection is weaker than for storm type 4 and storm type 6. So then we look exactly at the S2S predictability of storm type using an ensemble of 11 SCMWF runs on a 20-year period. We have to upscale the wet event, which are defined from hourly timescale to daily rainfall. So we attribute a day to a storm type when it is represented during the day and when it conveys the most rainfall amount. If a wet event lasts more than 1 day, we translate this storm type to both days. And we try to predict the daily rainfall for the 6 storm types. We use a score which is a probability of exceedance of the 95th percentile of daily rainfall at each station. So it is a score we use to evaluate the skill of the prediction. We compute it on observation and on each run and each lead time to remove any bias and any drift in the prediction. So we do that for each run, each lead time. So we have scores which are different, of course, during for wet and dry station. So it could be very different, of course. And we use it for each lead time and each run separately. So we compare the score we found with the prediction with 2 different predictions. One is the persistence, and one, it is a random forecast. So we just reshuffle, observe the storm type occurrence through the 20 available years. So here I present the probability of exceedance for the 6 storm type just for persistence. So you can see, it's not a big surprise, of course, that the score decreased very quickly from lead time 0, that is the day of the occurrence of the storm type, and then it decreased near 0 after a few days. So it's not, of course, a big surprise. You have a small clustering of storm type days when the events are very large, that is for storm type 6. But then after, you don't have any noticeable persistence of the daily rainfall. Here I compare the forecast for storm type 6, which is the dot with the bold line, with the persistence, which is the dashed line, the dotted line, excuse me, and the random forecast, which is the dashed line. you can see that the real forecast beats the persistent from day 2, and it beats the random forecast till 35 days. So it means that for this type of a storm type, we get a better forecast than random till 35 days, and we can assume that it is related with the occurrence of intraseasonal oscillation, the main mode of the intraseasonal oscillation, and we can assume also that ACMWF do a pretty good job to forecast this oscillation. Here you get the same result for the 6 storm type. So you can see that for storm type 4 and storm type 6, the forecast is quite accurate till more than almost 30 days. And you can see that for storm types which are more convective and more small scale, storm type 3 and storm type 5, it is far worse. The prediction is not so accurate, and we are very close to the random forecast after 7 to 10 days. So we can assume that it is partly due to the fact that the storm type 6 as the largest event. So we can just say that a large event is more predictable than a small event. It is not a big deal about that. But here in the bottom row, I decompose the scale for the storm type 3 to storm type 6 for different class of rainfall reached at the end of the event. And as you can see, the hierarchy, the ranking of the quality of the forecast, that is the better forecast you reach for storm type 6 before storm type 4 and then storm type 3 and 5, you can see that the rank is reached for any class of rainfall. Above 100 millimeter, I have not enough storm type 3 to get a reliable score. So we can see that it is not only a fact of the size of the event. It means that storm type 6, independent on its size, is better predicted than storm type 3 or storm type 5. So my last panel, it is to try to relate the duration, the size, and the predictability. So on the right bottom panel, you have a scatter plot between the duration on the x-axis and the area in emerg of the event. Okay, so you can see that longer the event, larger is the scale, and the storm type 6 in purple are the largest and the longer event. And on the left panel, I fit the quality, the accuracy of the forecast with the probability of exceedance with the area of the event. And you can see that you have a nonlinear relationship between the size and the accuracy. That is, the larger size are better predicted than the smaller size for 2 lead time. And still you can see that, of course, the storm type 6 in purple are better predicted due to their size rather than the storm type 3 and storm type 5. And storm type 4, it is closer to storm type 6 than the other storm types. So these figures show or suggest that the longer event represented by storm type 6 are better predicted by S2S forecast than storm type 3 and storm type 5, which are more smaller scale and faster, shorter event. So to conclude, the local intraday storm type, they offer a possible consideration of wet events through the intensity and duration. So it's a different perspective, I guess, from the consideration of average quantity as it is usually done. And of course, due to the ergodic nature of climate, they offer also, even if it is not used in their definition, they offer a view of the spatial scale. That is the longest event, that is storm type 6. They are also the larger event, and the small event, like storm type 3, they are also the shorter events. So two storm types 3 and 5 are possibly associated with very intense rainfall, but short duration and small area. And two other ones, which are related with slightly weaker mean intensity, but the total amount is higher, but they are less frequent, of course. They have longer duration and larger area. And these two storm types, 4 and 6, are more locked to the main intraseasonal and synoptic mode of variation than storm type 3 and 5. Storm type 2 and 1, it's a weaker event. They are very frequent for storm type 1, but they are very weak amount. We can imagine it is edge of the system or very scattered rainfall. Storm type 2 is probably closer to storm type 4 and 6 because it is weak, but it is basically longer event than storm type 3. It is clear also that storm type 4 and 6 are better predicted by the S2S ensemble I use from ECMWF. And this better predictability is fully consistent with the larger spatially coherent intraseasonal and synoptic scale precursor in the OLR variable. So there are possible future works I would be happy to develop with the Indian colleague if interest. I think that the main point is that storm type 3 and storm type 5, which are short and very intense, they can be very intense, they contribute to 40% of the total yearly amount in mean. That is, when we average over the 64 stations, the contribution is very large. So it may be interesting to look at the possible consequence of the potential and real-time predictability of seasonal amount, because we may raise the hypothesis that their contribution may be a limit of the predictability of seasonal amount, because they may be hardly predicted by any method, and then they may limit the predictability of seasonal amount, while the other storm type are better, they may be better predicted. But as they convey a large part of the internal variability, they may be, a limit for the seasonal prediction. We can perhaps assume, we raise this hypothesis, but it needs to be checked. Does a year with a lot of storm type 3 and 5 relatively to storm type 4 and 6 being less well predicted or not? We know that in the past we have a lot of failure of seasonal prediction. Maybe it related with a relatively large amount of this storm type, which may be harder to predict than the larger event. Another possible work is the relationship with risky impact as flash flood, because when you look, for example, at the hourly maximum by station related to storm type, it occurred during storm type 5 by 43% of the station, far behind storm type 3, 21% of the station and year. So it means that 64% of the station year annual maximum occurred during convective storm types. So they may be harder to predict, and perhaps there is a link about some event as flash floods. A last possibility is to use this framework in climatic change study, because usually climate change study use a time average or seasonal amounts, something like that. local or aggregated at the Indian or sub-region scale. And perhaps we can ask the question how the global warming may impact the occurrence of storm type, because we may assume that storm type 3 and 5 are more connected to local thermodynamical process, and perhaps their frequency will increase more than for storm type 4 and 6, which are more related with a regional scale process as a low pressure system. So I am finished. So thank you for your attention.
Thank you, Dr. Vincent Moran. So thank you very much for very good talk. Can I raise a question by a participant? Dr. Moran, are you listening me?
Yes, yes.
Yeah, one Miss Annalisa putting a question. S2S means the ensemble means, or is just one of the model that is used here? She is questioning this.
I just use one model, but I use each run. Each individual run is used because as we deal with a daily time scale, we think it's not accurate to take an ensemble by now. But I use only one model by now with 11 members.
Okay, thank you very much, Dr. Moran. So I thank you very much for your talk. So I am going next speaker. We are Dr. Rupa Kumar. Hello, listening, sir? Dr. Rupa Kumar ji?
Yeah. Go ahead.
So I am going to be my next talk by Dr. Rupa Kumar from Indian Institute of Tropical Meteorology. He is going to deliver talk on enabling S2S prediction, applications, WMO climate service information system operations. So I would like to invite Dr. Rupa Kumar ji for his talk. Over to you, sir.
Thank you, Dr. Mal. Good afternoon, everyone. And it is a great privilege and honor to be invited to present or make a presentation at this very auspicious conference, I should say. So let me start by congratulating my good friend, Sahai. I don't say Dr. Sahai because he's very much close to almost like a family member to me. I have probably one of the few having long association with Sahai right from the time he joined IITM. And in fact, we worked together, and many people actually associate him with only ERP or S2S, but he has a much broader interest and expertise that he has actually displayed at different points in his career. In fact, in the late 90s and also in the early 2000s, he and I worked together on climate change and downscaling. Actually, he was responsible for introducing the actual downscaled runs to IITM, which laid the foundation for IITM to become the main center in climate change in India, and also having international reputation. So Sahai's contributions have been immense, and in fact, his keen interest in getting involved in almost everything related to climate prediction, including the applications, is there for everyone to see. And in fact, he even meddled with operational responsibilities by spending some time in IMD. So that this kind of broad expertise actually is very rare to see. And I really congratulate Sahai for his contributions. And I consider myself lucky to be one of his associates. And he also supported me in some of my activities when I was in WMO. So that with that, actually, a brief introduction to my association with Sahai, I think I'll get to my presentation. Let me share my PPT. Can you see my presentation?
Yes, sir. Yes. Okay.
Yeah. Let me confess at the outset that I am by no means I consider myself as an S2S prediction expert. In fact, I have not really engaged in any meaningful way in this particular area. But at the same time, I would like to take you on a different route, closely connected to S2S prediction, but maybe zooming out and giving you a broader picture. So in that respect, this presentation will be a little bit light on the scientific rigor, but I'm sure you will appreciate that this will be quite heavy in terms of acronyms, which is actually one of the things that rubbed on me during my association with WMO for the past 1.5 decades. In fact, to start with, I will refer to the Global Framework for Climate Services, which is, I think, well known for many of the participants, which actually provides the context for us to take the S2S applications to the society through a major component of the global framework, that is the Climate Services Information System, which is one of the foundational pillars of the framework, and the S2S predictions, both in terms of the research advances and also the operational capabilities, feed into this particular component of the GFCS, where it reaches the users in terms of applications. So actually this was shown by Dr. Mohapatra on the first day, but what we see is that while we have, particularly in the weather to seasonal prediction domain, while we have the three different components or areas of prediction, this actually is, of course, more than almost 4 years old. But going by the excellent work that was presented over the past 2 days, I think we can actually lift the orange curve a little bit higher, and we have now the confidence to apply the S2S predictions that are being made available on an operational scale into specific decision making. So that is where I think we need to redraw this diagram in terms of the available skills and emerging skills. So that's an important aspect. And at the same time, this was also shown by Dr. Mohapatra, but I think this is useful to actually relook at this. We know that there are different types of user needs and the decision-making context with different lead times and different ranges of the predicted parameter. Based on that, actually understanding, we have to actually package the information that is being provided for specific applications to make sure that it meets the requirements in that specific context. So typically in the short range, we have basically warnings and humanitarian assistance and things like that. Basically, it is related to crisis management, but the risk management essentially takes into account the subseasonal predictions that are being made available, including the seasonal predictions, which are more than a month's time. So, but at the same time, we have to see this in the broader context for the entire climate change. I would call this a wholly special slide for the color that I have included here. But in any case, this is a well-known slide, well-known schematic developed by NOAA, but adapted at different times. So what we need to understand is that while we have the continuous kind of range of climate variability and change, the information is actually generated and provided in different ways and through different operational mechanisms. And this has to be stitched together in a seamless way so that there is no inconsistency from when we go from one scale to the other scale. So this is very important because the impact-based decision support in terms of preparing for the eventual outcome and getting ready with the responses and finally recovering or guiding the recovery efforts need specific types of information that has to be provided at with different lead times and also with different details that are required for decisions. And the climate services information system is actually designed to address that particular requirement. Actually, if people remember, the World Weather Watch was really a landmark in lifting the weather services to the current state. The World Weather Watch actually was a kind of systems approach in dealing with the meteorological science and its applications and how we can actually guide the society. So applying the same type of systems approach, how do we actually generate climate information and deliver to the community? So that is why this particular system has been conceptualized as part of the GFCS and is essentially characterized as the system needed to collect, process, and distribute climate data and information according to the needs of the users and according to the procedures agreed by the governments and other data providers. So this is considered to be the operational core of the GFCS, and this is where the S2S predictions that are actually emerging now and being widely recognized as very relevant to the user level decision making should feed into this particular system. The CSIS infrastructure layout has many layers, both in terms of global, regional, and national levels, but also in terms of data analysis, monitoring, prediction, and projection. So there are different players in each of these layers, and we have to make sure that the whole system works together, because even one area not meeting the requirements of the other area can actually disrupt the flow of information. So that is why the whole system has to work together in a smooth and collaborative way. We know that everybody cannot do everything. So it's important for us to recognize that and understand our roles, but at the same time make sure that we can work together in a smooth manner. So the implementation strategy, therefore, is in terms of defining the functional responsibilities of the CSIS in terms of data, monitoring, prediction, and projection, and also looking at the operational infrastructure required to produce and deliver those types of information, and the tools that are available for various activities and how to enable the communities, particularly the operational communities, in making sure that they follow all the CSIS requirements. So as part of that, capacity development is also in the implementation strategy. The CSIS actually, the output, as I mentioned earlier, though we have a continuous spectrum from distant past to the distant future, the information is actually generated at fairly discrete in areas. So that has to be recognized, and the outputs are generally flexibly generated at multiple levels and by different communities. and they are basically at levels global, regional, and national. But recognizing that most of the decision making happens at the sectoral level, particularly at the national level, it has to be value added at the country level, and the service delivery also happens at the country level. So this essentially is in the form of warnings like severe weather or flood forecasts, or climate watches, or subseasonal to seasonal forecasts, annual to decade climate predictions, and climate change projections. So these are the various ways in which the information is generated and produced. To facilitate this process, the WMO actually is in the process of deploying, or in the process of coordinating a number of operational mechanisms, some of which are already existing even before the global framework or CSIS came into the consideration. But at the same time, we have to actually make use of the available infrastructure to address those requirements. And the global producing centers are essentially WMO designated centers which produce global scale information. We have a mature set of GPCs for long range forecasts. We already have 13 centers designated so far, and one more actually from Italy is ready for designation. And India has recently applied for a designation because we also have the capability to provide global scale predictions. And there is a lead center in Korea, which is also set up in collaboration with NOAA to combine or to pull together all these global forecasts and provide to the WMO members in a real-time basis on a regular fashion. And there are also centers producing annual to decadal climate prediction. These are being coordinated by the UK Met Office. And now there is also a proposal ready for approval for subseasonal forecast, which actually is going to be the home for S2S predictions, which is, I think, in very advanced stages in the pipeline. Very soon we will see announcements about the GPCs on subseasonal forecast, which can become the entry point for S2S forecast into the CSIS. There are also discussions on GPCs for data and monitoring, which also I think can help us to meet the requirements of the entire range of products that are part of the CSIS. There are, at the regional level, we have a number of regional climate centers, which have a broad range of functional responsibilities. I will not go into each of them, but these regional centers actually focus on a specific region, and they actually take the global information and then regionalize that information to provide to the members within the region of their responsibility. RCC Pune actually is already designated as a WMO RCC. Dr. Pai has actually presented yesterday some of the activities of that regional climate center. There is also a third pole RCC network under development. India has been identified as the lead for the southern node, where again all the functionality of the regional climate center for the Himalayan region with a special cryospheric nature has to be addressed, and that is again another major responsibility for India. And there are also regional climate outlook forums worldwide. I think the whole world is covered now with these forums, which are platforms for climate service providers, the national Met services, and other stakeholders, including the users, to come together and look at the available products in real time and come to some common understanding of what these forecasts indicate and what actions can be taken at the regional level. While these forums originally were established as a kind of capacity development in many regions with developing countries, the concept actually also was recognized as very helpful even in areas where all countries are highly developed with advanced capabilities, like the Arctic. The Arctic Climate Forum, which is actually supported by all the members of the Arctic Council, is actively conducting its forum sessions, where though the countries individually are capable, they see a value for countries sharing common regional interests to come together and learn from each other's experience. So these forums have been quite successful in promoting the application of seasonal prediction up to now. But I think now with the maturing of the S2S predictions, it is time for us to introduce the S2S predictions in the arc of second. This is a busy slide, but at the same time, this was raised by the secretary on the first day. WMO is now moving towards Earth system modeling approach, Earth system modeling and prediction, and there is a seamless concept that is being applied. The GDPFS, the Global Data Processing and Forecasting System, has a number of centers, of which the GPCs and RCCs are also part. But on the weather scales also, there are many centers. So it's important for us to make use of all these entities to address the societal needs and also provide authoritative information on all scales, from weather to climate, and also on water aspects, which is also part of WMO's core responsibility. And there are a number of opportunities that are actually emerging out of the coupled modeling systems, and there is a great potential for seamless prediction across all time and space scales, which I think can be really facilitated by these various centers through WMO guidance. And in any case, we also need to involve the impact community, particularly the social scientists and all the sectoral scientists, to actually understand their needs and also how we can actually take into account the human behavior and response. I will also focus a little bit on the regional approach rationale, which is actually a major thrust that we are putting on the CSIS implementation. This is mainly because the regional approach to the development and application of climate information cannot be considered as an optional step. It is actually fundamental. For example, if you take our Indian monsoon region, we have so many countries sharing the same monsoon regime. And if each country does its operational work independently, there is a very clear possibility of inconsistency emerging, which can actually affect the decision making. So it's important for us to optimize the available global information in the regional context. And this actually is being taken up by WMO to demonstrate in a few target regions, and which can be actually upscaled later on based on that experience. So this is the regional approach that is being used to implement the CSIS. Essentially, it assumes that the required information, that is the data, the observations, they happen at the national scale. So they have to be pulled up to the regional and global scales. And the global forecast products that happen should actually be channeled through the regional layer. And finally, at the national level, the effort should be more on demand identification and sectoral applications, the products that are actually are directly used in decision making. So these are done in different ways. I will not go into the details, but it's very important to see that the regional approach is adopted in all the regions that have common regional climate drivers. So this is actually facilitated by what we call the Climate Services Toolkit, where we use a combination of push and pull, where you actually push some of the emerging technologies that we are able to develop so that the users who are not aware of these possibilities can look at them and then apply in their decision making. And at the same time, you use some kind of pull to understand the user needs and trying to address their needs. So the Climate Services Toolkit is a collection of the available tools. This is not developing any new tools, but it's just a kind of collection or a container for all the tools that can be provided in a properly linked fashion, in a customized way for the stakeholders. So one of the tools that we have is the so-called CLIMPACT. This was also developed as part of the GFCS context by WMO teams. So this is one of the examples of tools that we can provide to help users to convert the basic climate information into products that can be directly applied in their decision making. This is a freely available software tool, so you can actually look at the package and see if that can be applied to the S2S data. Similarly, we also provide a lot of guidance documents that can actually that can help members to better apply the available forecast products into the from global to the local context. At the national level, it's a kind of a different exercise has to be done through the GFCS. Actually, this was demonstrated through what they call national consultations, because in terms of climate sensitivity and climate response, there are a number of stakeholders at the national level who have to be brought together for the National Met Service, which is the primary climate information provider, to understand their requirements and to provide what actually they need. That is very important for us to go through. I think this is something that we need to do some additional work in India. We have started some at some level, but I think since India is almost like a subcontinent, it has to be done at a different level, even within the states, in their local languages, to actually understand their requirements and meet those requirements, and also to bring together all the stakeholders together. So the WMO actually is guiding this process through what is known as an expert team on CFS Operations. I have the privilege of co-leading this team with a number of colleagues from different parts of the world. So this team is charged with developing a number of deliverables which can actually facilitate the application of the CSIS. So I'll be closely following the S2S development and see how this can be integrated optimally into the CSIS operations. Finally, as I come to the close of my presentation, I want to say a couple of words about my present responsibilities here as leading the International Fly-War Monsoon Project Office. We are moving towards an international monsoon project office, expanding or consolidating the work that is done as part of the ICMPO. So we are going to support the whole monsoon research around the world conducted through both WCRP and WWRP and all their teams and various bodies. And in that context, I am also happy to see that a number of the CLIVAR QX Monsoons panel are also participating in this conference and have made excellent presentations. So this is very much encouraging, and I hope to see a greater thrust in the IMPO operations or IMPO activities to deal with S2S predictions. We also have recently taken up a major initiative to have an S2S training workshop, which is actually a pilot activity in the run-up to the 7th WMO International Workshop on the monsoons, which is expected in early 2022. It was supposed to have been done this year, but we had to postpone because of the pandemic. but we are going ahead with a training workshop in the virtual form. An international organizing committee has been formed, which is right now, as we speak, is discussing the organizational elements of the workshop. And as part of the Monsoon Project Office, we'll be providing all the required organizational support. And finally, in terms of way forward, what I would consider important is that India has to pursue the global producing center roles. A number of opportunities are emerging, and I think with our capabilities in global prediction, I think we have to get into that so that it makes us part of the community and helps us to improve our capabilities and also provide our resources, our contributions to the global community. The RCC products have to be enhanced. RCC Pune and the proposed the third pole RCC network, they have to actually get into the S2S predictions and make the S2S predictions available to the region of their responsibility. And similarly, the arc of product portfolio has to be expanded, including S2S products. There should be sustained climate services user forums, which I think are relatively weak at this point of time. This is very important for us to be able to involve the user communities in the packaging of the climate information products, which can be directly applied in the decision context. So in that sense, I think that there is a lot of work to be done at the national level and also expanding the national climate forums. We have started actually highlighting this issue in different forums, and I hope we will get a stage where each state will have a climate forum in its own local language, which can further enhance the application of the S2S products. And there should be also a greater and sustained engagement of regional implementation partners. There are a number of partners. The most important, most visible partner is RIMES, which actually is doing excellent work in many countries. So we need to partner with them to actually address these issues. And finally, there is a need for regional consolidation and complementarity of investments. Actually, a rough calculation some time back has shown us that nearly $1 billion is being invested in climate services in different forms, but they are not well coordinated or they are not consolidated, with the result that there's a lot of inconsistency and also duplication of effort. So I think we need to work towards a regional consolidation. I think some beginnings have been made to achieve that, particularly the remarkable progress that we have made.
May I request you to please conclude?
Thank you.
Finish?
Thank you.
Yeah. Over to you, Professor Mal. We can invite the third speaker.
Yeah. Okay. Thank you, Dr. Professor Kumarji, for nice talk. So I would like to invite next speaker, Dr. Hunt. Dr. Hunt, are you here?
Hello.
Yeah. So Dr. Hunt from University of Reading, UK, and he will talk on monsoon depression in S2S models. So over to you, Dr. Hunt.
Thank you. There we go. Hopefully you can all see that. Yeah, so I'd like to echo Rupa Kumar's points that he started with. So firstly, to congratulate Dr. Sahai on a very successful career. I met him briefly once in Reading when he came for a visit, and we had a very productive chat about Western disturbances, I will remember, for a long time. And the other point I'd like to echo is that I also do not work in S2S forecast at all. So I was very excited to be given the opportunity to talk, but I did have to think about the topic I'll talk about. Luckily, I have a PhD student, Akshay Dioras, who I co-supervise with Andy Turner, and he is working on S2S forecasts in and looking at monsoon low pressure systems and monsoon depressions in those. So I will be presenting essentially everything here, his work that he's done as part of his PhD for the first 2.5 years of that. So yes, I guess an introduction is probably briefly necessary. So depressions and low pressure systems in the monsoon are synoptic scale systems. They bring a vast majority of the monsoon rainfall. If you look at any of the attribution studies, you find that over the monsoon core zone, for example, they probably bring at least half, if not 2/3 of the rainfall, depending on how you measure it. But not only are they responsible for the climatological rainfall, they're also responsible for a majority of the extreme rainfall events that occur. And you can see down here this plot from Teresa Thomas's paper that was out earlier this year. And they found that almost all of the extreme rainfall events that occur in the monsoon core zone come about in the locale of it. Sorry, I'm just putting the pointer on. But almost all of the extreme rainfall events that occur in the monsoon core zone come about within a few hundred kilometres of the centre of a low pressure system. So obviously it then doesn't take a large leap to understand the importance of forecasting low pressure systems and monsoon depressions on subseasonal timescales. It will help mitigate against flooding on the shorter timescales, but also help with things like agricultural planning on the longer timescales. So what ACSHE has done is to track low pressure systems in all of the 11 S2S models. So this is the S2S dataset that is a multi-institute collaboration. Frederick talked about at some length in his talk on Monday. So there are 11 reforecasts. There's a common period of reforecasting between 1999 and 2010. And that's what we'll focus on. Mixed ensemble sizes, so wherever a model has got more than one ensemble member, we've tracked in all of them. Actually, it's done the tracking in all of them. And then those results are averaged that you'll see. But you can see here that there's a real mix between the models in terms of resolution, from BOM, which is incredibly coarse with very low vertical resolution, only 17 vertical levels, to those that are much higher, quarter degree ECMWF and nearly 100 vertical levels. And there's also a mix. Some are coupled with the ocean and some are not. So the first task is to sort of modify your track algorithm so that it can pick these systems up. The difficulty here is that these S2S reforecasts are daily frequency. And in being daily frequency, tracking synoptic scale systems can be challenging. We are used to using them on reanalyses where the frequency of output is 6 hourly or even 3 hourly or even hourly, which is a real luxury. But when you have to move to daily frequency, you have to think a little more carefully about how you go about it, because it can be difficult to connect neighbouring candidate points together. So we had to add in a few extra filters to make sure that what we were tracking were actually depressions and or low pressure systems, and that they belong to the same one. And those generally came along the lines of a temperature anomaly filter in the lower troposphere to make sure that we weren't tracking heat lows, and negative surface pressure anomaly just to help to tie things together. All of this tracking is done in an NWP framework, so all the results you see, I know this is an S2S talk, but we've limited everything to the first 15 days of the reforecast, so we're just touching on the S2S time frame, I suppose. And later analysis will go into the longer forecast, so we will look more at the seasonal aspect of things, but for the time being, we will deal with the shorter timescale. So this is what these are some example tracks from the 1999 season. So in the top here, you've got 2 reanalysis products, ERA1 and ERA2, and then I've just chosen four S2S results, random ones from ACSHE's paper on this. And you can see that there's some variance indeed. Some have very sparse track densities, and some have more complicated track more dense activity, and they are spatially very variable as well. So there's going to be lots here to do analysis on. So firstly, we'll do the sort of standard verification of reforecasts. The important thing to to point out here is that as part of the analysis, we've linked each of these tracks in S2S models to if we can, to a real track in reanalysis, so that we can perform slightly more robust error analysis. That's usually not too difficult to do. There are a set of algorithms that allow you to do that, actually developed and following the literature. But the result is that as you go further in, as you increase lead time, you end up with fewer data points, basically. So the position error, this is the tracking error. So this is the difference between the point in reanalysis and the point in the S2S model. Increases with lead time, as you would expect, starting from pretty close and spreading up to about 1,000 kilometers. And that's consistent whether you use Trackster and Meritor or your interim. The interesting thing to note here is that if you were to compare this to results for tropical cyclones, which I've brought from down here, this is a figure from Kevin Hodges and Rebecca Emerton's monthly weather review paper. You can see that the mean location error at lead time about 2 weeks is about 12 to 13 degrees. It's much lower, about 900 to 1,000 in our multi-model mean. The reason for that is because the low pressure systems are geographically constrained where tropical cyclones aren't. Low pressure systems can't cross the Himalayas, for example, and the basins that they spin up in are much smaller in terms of area than the available basins for tropical cyclones. So there are those constraints which help and therefore help us in terms of subseasonal prediction. And you can see as well, and I'll talk. Oh no, okay. Never mind. So for intensity, you can see that most models fall between the two reanalyses in terms of intensity bias, and there's no systematic trend in intensity bias, so the models aren't all either over-predicting intensity or under-predicting intensity as lead time grows. So a little bit more on the track position error stuff. So this is looking at spatial map, and this is looking at the growth of those forecast errors in track position by taking the spatial map of track errors 12 to 15 day lead time and subtracting the error at 0 to 3 day lead time. And you can see that the error doesn't really grow that much over the Bay of Bengal and the monsoon core zone. Again, this is because tracks in these areas are generally quite well constrained. If you have an LPS, if you have a strong monsoon trough, an LPS sort of has to go into it. Otherwise, it's fighting for space. What does happen is that you get very significant error growth over the Arabian Sea in just about all of these models, and that's because tracks that tend to pass over the peninsula can end up either heading south or north or central, and they become a lot less constrained in terms of their location. And that presents a difficulty in terms of long-range prediction of extreme rainfall events over the Arabian Peninsula and Iran and Pakistan. So looking at the system intensity, as I said before, most of the models have a mean intensity that tends to fall in between the two reanalyses, which is good news. So each of these histograms represents the intensities measured at 850 hectopascals. That's the relative vorticity at 850 hectopascals in each model. And then you have a probability density estimate curve overlaid in magenta, and then the two reanalyses are in orange and cyan. Like I said, most of them, in terms of the mean and mode, fall within the range of the two reanalyses. Where we see some real divergence, though, is in this right-hand tail. So some models are very unkeen to develop stronger low-pressure systems and stronger depressions. For example, HMCR has got almost no systems in excess of 5 times 10 to the minus 5 per second. Whereas some models spin up a lot more NSEP, for example, ECMWF, and have much stronger systems. So we'll start to look at why those biases exist in a bit. But first, let's talk a little bit about how precipitation biases go in these models. So this shows the mean precipitation error for each model for monsoon rainfall over the common reforecast period, that's 1990 to 2010. And the left-hand side for each model shows all days June to September. On the right-hand side shows just days when an LPS is present. And if you compare each pair, basically you see that the error on LPS days looks very, very similar to the error for the mean. And the top right-hand corner shows the spatial correlation coefficient, which is usually in excess of 0.99. So what we can deduce from this is that where you have a climatological bias in these in the first 15 days of these S2S models in rainfall, it's usually coming about because either directly because of the misrepresentation of an LPS one way or another, or the LPS, an error in the LPS is manifesting and interacting with the larger scale, which you might suspect is what's going on in CMA, which has these very significant positive rainfall biases off the Western Ghats. Now, in some cases, you can make some comments about what the cause of these biases might be. For example, in Isaac CNR, it's very obvious where you have a wet bias along the foothills and dry bias over the monsoon core zone, that what's going on is you probably got LPSs that are traveling too far north. In some other models, it's not so obvious what's going on. And we'll need to delve a little deeper into structural biases to figure that out. So just before we get into that, we can see whether the monsoons in the models are self-consistent in terms of interactions with LPSs. And one way to do that is to look at the rainfall attribution. So we take, following previous literature, we take any rainfall that falls within 800 kilometers of the center of an LPS and say that that rainfall has been caused by the LPS or depression. You sum all that up, and then you divide by the climatological mean monsoon rainfall for the model, and you get an idea of how much rainfall for each monsoon is caused by LPSs in each model. And you see that they are actually generally quite consistent. So down at the bottom here, you have the two reanalyses, ERA interim and MERA 2. And you can see that most of the models fall within that in terms of magnitude and in terms of the sort of hotspots. So there is a bit of a split here. Some models like KMA and NSEP have a maximum quite far south, but that's not inconsistent with the reanalyses because we do see that too in MERA 2. Whereas other models, ECCC, BOM, JMA, for example, have the maximum a little bit further north, which is generally a bit more consistent with what we expect. But what this shows is that the way that the LPSs are interacting with the monsoon in the model are probably consistent with reality. So let's have a little look about where the sources of the biases that we've seen, where do they come from? One way to probe this is to look at the composite structure of these systems. So these are composite precipitation footprints for LPSs in each of the 11 S2S models and for ERA interim in the bottom right, which is computed using, so it's a ERA interim tracks computed with GPM merge rainfall. So most models, in fact, all models really get the location roughly right. So we know from quasi-geostrophic theory that rainfall in a monsoon depression, because of the nature of the vertical shear of the environment, must fall in the southwest, to the southwest of the centre. The west. Losing my voice. Must fall to the west or southwest of the centre, and most of the models capture that. Either they're getting it, relatively far south or relatively far west, but they're all getting that. It's the difference really is the magnitude. So some models have got very, very weak rainfall, like HMCR, and some have got very, very strong rainfall, like Isaac CNR, which is consistent with the rainfall biases that we saw a few slides ago. So what is causing these differences? Because these intermodal differences are clearly very significant. And it's always good to fall back on the thermodynamics if we can. So the thermal structure of LPSs is quite well understood. You have a warm core aloft. That's caused by the latent heating of ascending moisture flux that's condensing out in the mid-troposphere as it hits the freezing level, saturation level, sorry. And then in the lower levels, you have a cold core, which is caused by perhaps the evaporation of precipitation mixed with cloud blocking insulation. The general thermal structure is captured quite well in most of the models, and in particular by those models with more accurate rainfall. So it shows that the thermodynamics, as we would expect, are linked to the rainfall. So those models with the best rainfall also have the best structure: the UKMO, NSEP, ISAC-CNR, ECMWF, CMA, for example. And those models with very weak rainfall have this very weak heating pattern, which indicates either that it indicates that something is probably wrong with the convection scheme. So we know that the rainfall in depressions is mostly stratiform because it's caused by, it's diagnosed as stratiform because it's largely caused by large-scale moisture flux, but embedded within those regions of large-scale moisture flux, you will get air masses that are dry and moist being wrapped in together, creating convergence lines on their boundary, as you have fronts in theta E. And along those fronts, you can get convective organization, which is really important for the development of the rainfall and the thermal structure of these depressions. So if either of those is not being well simulated in a model, it will result in a dry bias in the depression because they're simply not producing enough vertical moisture flux one way or another. So we can tie this through QG theory again into the structure of vorticity. So if obviously to first order, if your cyclone is too weak, you're not going to be producing strong enough large scale updrafts to give you the vertical moisture flux that you need. To second order, we know that differential vorticity advection through QG theory is important in driving ascent as well. So not only is the shape of the vorticity important, not only is the magnitude of the vorticity important, but the shape of the vorticity in the mid-troposphere is important too. So where that tails off, where that the vertical gradient is too shallow, we're not going to be driving mid-level omega sufficiently well. Now you end up with a chicken and egg problem here, of course. Is it problems in the vorticity driving the ascent and therefore the rainfall, or is it problems in the vertical moisture flux in general that then do not seed the depression enough and result in insufficient intensification? We'll need to do more work to find out which that is, presumably through denial experiments or something like that. But what we see again is that there's a pattern here. Those systems that are weaker and have lower vorticity, those models that have lower vorticity systems are the ones that have the dry rainfall bias. So I'll summarize that work briefly. So we carried out we did tracking of depressions in all the S2S reforecasts, which was a good piece of work in its own right. You find that forecast track error is generally less than it is for tropical cyclones for the reasons I discussed. They're geographically constrained, and intensity biases generally fall in between the two reanalyses, at least in the lower levels. The upper levels is a bit of a different story. And we think that the errors in precipitation will be linked through a cascade of effects to convective organization, through convective organization and into things like the large-scale organization of convection that the models are not getting perhaps exactly right. So the outlook, which will be basically the stuff that actually is going to work on in the last few months of his PhD, is going to be extending this sort of analysis out to seasonal timescales and asking the question, well, how well do these models predict the frequency of LPSs in a monsoon season a few months in advance, and what are the large-scale controls on those, and how well are the relationships, the teleconnections perhaps between NSO and the monsoon, how well are those relationships captured in S2S models? So I'll finish there. Thank you very much.
Hello. Thank you, Dr. Hunt, for a nice talk on monsoon depression as to us. Any question from participants? Anybody? Over to...
Yes, I have. I am VB Rao from Brazil. Hello?
Hello.
Yeah, I have a question, please, regarding the origin of the monsoon depressions, what exactly is the mechanism of the generation? Baroclinic instability, or as Murthy and Arakawa suggested, it is due to the interaction of instability, baroclinic instability, together with heating. And they, in their study, they said monsoon depressions are actually something like the large baroclinic instability, or what they call green smots. Can you suggest something about this, please? About the origin, because the basic problem in all these errors is because of the lack of the mechanism of the generation, I think.
So
Okay, thank you for
it's
your
a
nice
very,
talk.
very good. It's a very pertinent question, and it's something I think. So it's something that you need to separate into two parts. You have the actual physical genesis itself. So there needs to be some seed vortex, and then there needs to be some mode of intensification that converts what is essentially a small-scale eddy into some large monsoon depression. Now, the second part of that, the intensification, is still something of an open question in the literature. There are a lot of recent papers from Bill Boose's team that suggest that it's actually moist barotropic instability. They did try and prove it was moist baroclinic instability, but essentially ended up showing that that was that the shear combined with the axial tilt of the depression was incorrectly aligned for it to be a baroclinic growth.
Yeah, I am aware of that paper by Bush in Quarterly Journal. But what I think, in the case of monsoon depressions, there is very strong vertical shear, and a barotropic theory is only what you call incomplete, I think, because the shear is very, very strong.
So I hadn't finished my answer, and the second half of it is the work done by Angel Adames Corraliza, which looks at the so they propose this moisture vortex instability theorem, whereby vortex essentially destabilizes within the environment. So that would be baroclinic in the sense of having a theta E gradient or theta W gradient, but it doesn't so much rely on the wind shear. And the other part of the question, which is perhaps just as important for S2S prediction, is the genesis of depressions. You know, where do the seeds come from? And I know there was some work done at the Met Office by Richard Levine and Jill Martin, where they did a limited area model over the monsoon region, and they did a control experiment where they fed in at the boundaries real analysis information, typical model information, and a test experiment where they just fed in climatological means, and they found, Jill's probably here and correct me on this, but they found that in the experiment where you just have mean conditions coming into the boundary, you get very, very few depressions spinning up, which indicates that the information that they need, the vortical information that they need, the entropy, if you will, is coming in from outside. And that's something else that these models will need to capture, particularly if they're going to get the frequency right on longer timescales. Obviously, on the shorter NWP timescales, that information is probably already there because it's already started to spin up in one way or another. But in terms of tracking these vortices over from perhaps the South China Sea or Northwest Pacific.
Thank you, Dr. Hunter. Thank you.
Okay.
Thank you, Dr. Hunt. One question from a guest. What is the effect of high vertical wind shear on monsoon depressions? He is asking.
Yeah, again, another important question, and I'm not sure that we really know the answer. So some authors have found that it can help the growth. I think, in fact, Murthy and Arakawa's paper on that suggested that it would be the wind shear scaled with depression growth. Some have found that it's perhaps not helpful at all or even slightly detrimental. So Sarah Ditchek did a paper on monsoon depression genesis conditions and looked at a bunch of stuff and found that wind shear was perhaps very slightly detrimental. I guess the answer is at the moment we don't know, more work needed. I certainly don't know, and I wouldn't want to speculate. Whenever I write this in a paper introduction, I'll always say it's an open question.
Okay.
Perhaps it depends on where it is.
Yeah. Okay, thank you. So any question from other participants? Any? Hello? Okay, over to Professor Misra, Professor Bimal Misra, listening.
Yeah, I'm here.
Any comments from you? And
no comments. All the three talks were, absolutely wonderful, covering range of topics related to seasonal to sub-seasonal prediction. First talk was from Dr. Moran, who sort of presented very important work regarding different storm types over India and how and what kind of predictability is associated with different storm types. And then second talk was, of course, from Dr. Roop Kumar, and who presented very detailed ongoing activities and future plans of the related to S2S, under the leadership of WMO. So that was, I think, in days to come, we will see a lot of progress in S2S. And I mean, we all know that application of S2S prediction over India is extremely important because of two very important sectors. One is water and then other is agriculture. And so we can make a lot of difference if we make progress in terms of improving the predictability or the forecast skills of different variables. And third talk was regarding the monsoon depression by Dr. Hunt. So I would like to thank all three speakers, and now floor is open for general discussion. So if you have any comments or any questions further from speakers, we can take one or two more questions before we can move to the next program. So thank you.
Thank you, sir, for chairing the session. Now I request all the speakers, chairs, Dr. A.K. Sahai and other delegates to kindly switch on their camera to take a photograph.
तुम्हारा नहीं आ रहा है, इधर आ जाओ
Thank you, sir. It's done. And thank you all once again. Now we'll take a very short break since we're too late, and we'll meet at 10:10 UTC or 3:40 PM Indian Standard Time for the valedictory program. And at the end of this valedictory program, we wish to honor Dr. A.K. Sahai, Scientist G, Program Director, Monsoon Mission, for his remarkable contribution in the field of S2S in particular. So all are requested to join this valedictory program to make it more successful. Hope to see you all in 10 minutes. Thank you all. Yes, where should I sit? First move.
Seasonal prediction project of MJ. Dr. Rajivan, in the inaugural address, has emphasized that India is looking for strengthening the dynamical forecast, monsoon mission coupled modal development, soil moisture, high resolution observations, and the development of mooring in the oceans, and the plan to augment the present HPC from 10 petaflops to 30 petaflops. And in the opening remarks by Dr. Estella Koning has emphasized that the need of improvement for the S2S forecast scale and the need for societal changes for the high impact weather, water, urbanization, and new technologies. In the last 2 days, we have seen high intellectual and informative lectures which covered all timescales from short, medium, extended, and seasonal and to climate. The lectures not only brought out the present challenges in the S2S prediction scale, but also a way to move forward. And S2S predictability for the health sector, agriculture, river basins, low pressure systems, depressions, DRR have been discussed. Challenges for the seamless modeling systems and its efforts and how it affects the timescales have been also discussed. A few talks have highlighted the importance of AIML techniques in the S2S scale. One school of thought is that the AIML is to be proxy for the S2S predictors in improving the S2S scale. Challenges are there in the for the seasonal prediction, as we have seen the skill is poor for the South Asian region, especially over land. But advancing tools and collaborations build a hope for the upliftment of S2S prediction and making it available for the users, ultimately benefiting the society. There are talks on the strong link between the South American monsoon and the Indian summer monsoon, and the low skill in predicting the South Asian monsoon, rainfall over land has also been discussed. So with this, I invite our esteemed experts, Dr. Estella Koning, Dr. Frederick Wittart, Dr. Andrew Robertson, Dr. Mahapatra, Dr. R. Krishnan, and Dr. A.K. Sahai for the panel discussion. First, I start with Dr. Estella Koning for her remarks. Dr. Estella Koning. Okay. Okay, we start with Dr. Andrew Robertson for his remarks.
Good day, everyone from New York. Thank you very much for the opportunity to give a few remarks. And it's been our pleasure in the S2S project to co-organize this important meeting with IITM and our Indian colleagues. I must apologize for not having been able to attend too many of the sessions because of the time difference. But from the program and from the summary that was just given, it's clear that this has been a very important conference. And this is something in the S2S project that, as you may know, we're in our second phase of S2S, and it's coming to a conclusion at the end of 2023. And one of our goals has been to build community around the world on improving, understanding better the S2S timescales, improving prediction, and also improving uptake for applications, future applications of early warnings, new climate services on these timescales. So we'll actually be starting some new regionally focused initiatives in the last few years of S2S. We're just revamping the S2S website at s2sprediction.net, and there'll be a wiki page there for South Asia, and so we're very much looking forward to pushing this aspect forward, especially thinking about the legacy of S2S and how that can be used in the future in climate services over South Asia. We heard about some of the challenges in S2S prediction with large noise over land in precipitation over South Asia, but at the same time there are strong, as we know, strong signals in the intra-seasonal oscillation, and ENSO is also impacting the region. So we're confident that there's scope for especially forecast of opportunity at times when those signals are strong for making forecasts several weeks ahead, certainly into week 2, sometimes week 3 and 4, perhaps when the monsoonal intra-seasonal oscillation is strong. So we think we see a lot of opportunity for developing climate services on these time scales, thinking about really seamlessly. That's been one of the things of S2S, really linking the weather and climate communities. So to develop seamless climate services using the concept of ready, set, go, to be able to really target forecast information on at different lead times to different decision points in the agriculture tactical management, such as irrigation, fertilizer application, and so on and so forth. One of the things in India we're very excited about is the creation of the new WCRP, WWRP project office in Pune, and we're really looking forward to working together going forward on that. And one of the other things in S2S that we've really been pushing has been the training. So we've had, as you know, we've had many trainings around the world, and we're looking forward to more activity there in bringing the experience and knowledge that the community's developed in the S2S project to develop the better, more skillful forecasts using techniques such as calibration, multi-model ensembling to improve the forecasts. As you may know, I mean, machine learning has been highlighted in this conference, and the S2S project is actually organizing now a competition. It's going to be a global competition to harness the S2S database and machine learning to improve forecasts. So everyone will have an opportunity, the machine learners among you, to compete. The WMO has put up a small monetary prize, and that's going to be coming online. So we're hoping that will start in June or July of this year. So please look out for that. So thank you very much for the opportunity to give some introductory remarks.
Thank you, Dr. Robertson, for your kind words. And we look for in June, July for the AIML workshop, which we will try to participate in that. Now I invite Dr. Frederick Mittart for his remarks. So you're muted. Sorry, sir, you're muted.
Yeah.
Your voice is not.
Frederick, we are not able to hear it. No, still it is not.
Okay.
No.
The problem is with the headset.
There is some problem. You may again log in. Log out and log in. You are not, we cannot hear you.
Okay. We will wait for Dr. Frederick Mittart.
Yeah.
You can call next.
Sorry, sir, you're not audible.
He has to speak something.
Yes, sir.
No.
No, sir.
Next panel expert, Dr. R. Krishnan.
Okay, can you hear me?
Yes,
sir.
Yeah. So first of all, I want to thank the organizers and all the speakers and this participant. It was a wonderful event. I attended many of the talks, but not all of them. It's an extremely very well organized event, and I really enjoyed many of the presentations. And so I want to congratulate everyone on this. So first of all, what I would like to say is there is a remarkable progress in the S2S prediction that we see from different centers, because when I compare with about 10-15 years back, where now the present situation, I think there has been a tremendous improvement from centers around the world in terms of the prediction skills, and also from India, and particularly under Dr. Sahai's leadership for the extended range prediction. This activity has progressed extremely well, and not only the prediction of S2S, also its application of the S2S forecast for various applications, hydrological applications, health, and so on, and various products are being developed. So that is a very encouraging to see that. And it is also wonderful to note that from India, IITM and IMD will be contributing to the S2S database, the prediction, which will be featuring in the WWRP list of participating agencies from around the world. So this is a very significant development, and we are really looking forward to this. With regard to the scientific challenges, I heard Dr. Andy Robertson's thoughts. So when it comes to the MJO still the prediction skills are better, much higher skills are seen because of the ISOs located propagating over the ocean. And when it comes to the off-equatorial land area precipitation, so the ISO prediction skills, especially the summer monsoon ISO skills, appear to be much lower. And so this clearly, I think this is something that needs much more basic research in understanding the precipitation processes and the variabilities on the subseasonal scale, especially the MCS, heavy mesoscale convective systems, and how they organize in the monsoon environment, orographic precipitation, which is also very large in the region, and also the fact that the latent heat of condensation due to the water vapor condensing and forming clouds, they can interact with the circulation and on a continental scale. So these are still, we have made progress, but still these are topics for research. So a lot of basic work is needed, and improvements in the model physical parameterizations will be required in the coming years to improve the skill further. And also, although we say it is subseasonal scale, there are multiple scale interactions involved in this. For example, links with the tropical Pacific SST gradients, the El Nino, for instance, and large-scale circulation changes. So these are inherently challenging problems, and especially with climate change, this is going to be an important issue. And how these heavy rain events on the intraseasonal time scale are going to change. So these are important topics. We need to improve our models. And also, I personally feel the data assimilation of both the atmosphere and ocean, we need to strengthen that. If we want to make further progress, major step changes in the extended range prediction, data assimilation will be a very important key. And so there is one hand on the, we need to do basic research. At the same time, there is a operational requirement of generation of forecast products and applications. So these two are two different things, but they have to go hand in hand. So basic research is a more time consuming, more slow process. Operational forecasting, yeah, it has to go on. It's a much more, requirements are more urgent, and that has to go on. So these two, although they are different time scales, they have to go hand in hand, and a very good coordination is important for this enhanced coordination between the basic research and the operational requirements. So these are my personal thoughts, and otherwise I enjoyed this workshop very much, and thank you very much for this opportunity, and I want to congratulate everyone for the excellent outcomes. Thank you very much.
Thank you, Dr. Krishnan, sir. Now I invite Dr. Estella Koning for her remarks. I think Dr. Estella Koning has joined.
Good afternoon. Yes, it was surely an interesting few days. I could not attend all of it, but it was really good to hear about the basic science and all the advancements that have been made, especially in your region. And then also I enjoyed Kumar's talk this morning, bringing it very close to all the, not only the acronyms, but also the applications in the region. So for us, it's really important that we look not only at the fundamental science, which of course is really important, but that we also look at how we reach that into operations. And I think we saw some clear examples of that already going on in the S2S project, of which we are really, really proud. And of course, we also acknowledge the fantastic work done by Prof. Sahai, not only in your community and in India, but also as a member of the WWRP Scientific Steering Committee, and we acknowledge his wonderful career. Thank you so much.
Estella Koning, for your kind words. Now I invite Dr. Frederick Mittat, if his microphone is working now.
Sorry, sir, we are not able to hear you.
Yeah,
now it works?
Yes.
Okay, so sorry for the technical problem. So thank you for the opportunity for letting me have in a talk. Now, I certainly also enjoyed very much this workshop. As the previous speakers, I have not been able to attend all the talks due to the time difference, but I certainly really enjoyed everything I heard. So as S2S co-chair, I will echo everything that Andy said. I think what is very important to point out that one of the goals of S2S is to pave the way for a seamless climate service. And the fact that India also will host a WWRP, WCRP project office for monsoons will be quite a very important step forward, and very important for the international collaboration. So as has been said before, I mean, there has been over the recent years a lot of improvement in the model in the model forecast. We have seen that for the Madden Association, but there's been some very important improvement by a gain of about 10 forecasts a day. For the monsoon, there has been also a lot of improvement, but the model still struggle also to produce still could still be under 2 weeks. Although there is still some windows of opportunity where we can find some reasonable still. So there's still some important challenges in front of us, and I think that's some topics that the S2S project tries to address. And some possible route for improvements could be to increase the complexity of models. For example, the addition of interactive aerosols is something that is one of the sub-projects of S2S to try to investigate what would be the benefit on the meteorology if we had a fully interactive aerosols, and also on the prediction of the aerosols themselves. The benefit of a larger ensembles could be is also another avenue that is getting explored. Are 50-member ensemble even enough now? Should we have 200, a much more larger ensemble to really assess better to have a better assessment of the probability distribution functions? We've seen also in this workshop that the soil initialization, the soil plays really a very important role. Not only the soil initialization, also the good representation of soil processes need also to be explored. And from the ocean point of view, the RC interaction, the good representation of the diurnal cycle in the Indian Ocean needs also to be better tackled in the model. So in the S2S project, we also have OSC experiments to try to determine the benefit of the current ocean observing system. And one goal is to also give recommendation of where we should better observe the ocean. And I think for the monsoon, that could be quite an important. So we stop there. So saying again, thank you for this invitation, and congratulations to Dr. Sahai for all this accomplishment. I think it has been really a huge contribution to the community. Thank you.
Thank you, Dr. Fajr. Yes, strengthening the S2S community also would mean that data exchange in the S2S database. In this regards, IMD and IITM is trying to keep the ERP data in the S2S database in the coming few weeks from now. Okay, now I invite Dr. A.K. Sahai for his remarks.
Yeah, it was a really very good symposium organized by S2S project and IITM IMD jointly, particularly for applications in the South Asian countries. And during the last 3 days, several experts have discussed process, predictability, prediction, and need of a strengthening observational network, then skills of model development and societal applications of S2S forecast. It has been also emphasized with various groups that they have achieved predictability, but still potential predictability is much more has to be achieved, and further work is required to improve the predictability prediction score. Particularly, if you see the applications, Dr. M. Mahapatra, Dr. G. Srinivasan, Dr. Giriraj Amarnath, and Professor Raghu Murthy, and many other, they have shown that how S2S predictions are being used for agriculture, hydrological, health, and disaster management in India and in South Asia. So this was very much encouraging. But two presentations, one by Dr. T.M. Balakrishnan Nair on societal applications of S2S predictions for ocean and coasts, and other by Dr. Vinu Balsala on application of extended range prediction ocean ensembles in developing marine biochemistry deliverables, a future perspective. So these two were really very remarkable, and this has shown the way how S2S prediction can have much more societal applications. So we have to work very hard even for various application also. But as far as IITM participation in data sharing, still we have not started sharing, but very soon we will be sharing this data, which is our operational forecast. And very soon we will be starting real-time forecast with our advanced version, which is showing more prediction skills. And we will work with IMD, RIMES, and International Water Management Institutes and other societies, WMO, S2S, to have more applications in the society of South Asia. Thank you.
Thank you, Dr. Sahai. I invite Dr. M. Mahapatra if he has joined. Dr. Mahapatra. Dr. Mahapatra. Okay. I invite other people who can have some comment on this. Yeah. Is anyone interested?
So, do you want to say something on consumption activities and S2S?
Okay, we conclude here, and I hand over to yes.
Hello.
Yes, Dr. Mahapatra.
Hello, I'm Dr. Tyagi here.
Okay. Yes, sir. Yes, sir. You can.
Okay. Am I permitted to share my views?
Yes, sir.
Well, Dr. Sai has very aptly summarized the deliberations of last 3 days and scope for future development. And I must compliment Dr. Sai for I have done when I was chairing my session yesterday. But let me reiterate and his contribution, because I had seen this particular initiative taking, nascent in early parts of last decade, and last 10 to 12 years he has matured it, created a team, and contributed to the applications. It's not only the science part, but he has contributed, worked very closely with all the application users, and then been able to develop products for various sectors. So this is really heartening, and he has created a place for IITM, IMD in the S2S community, contributed to the South Asian countries, and also now the world platform. So it's really heartening to see Dr. Sai's contribution, and I'm sure he will continue to support the S2S initiative, which is so much needed for the societal betterment, particularly in the developing countries like of South Asia, Southeast Asia, and Africa. So let me again compliment him, and also compliment the organizers, particularly the Director IITM and the organizing committee, for have considered this particular important virtual conference with the superannuation of Dr. Sai. It is a befitting farewell to him, honoring him, acknowledging his contribution, and also supporting this initiative in this part of the world. Thank you.
Thank you, sir. Is anyone interested to comment?
Honey, I can speak few words.
Yes. Yes.
Yeah, actually, I was incurring DG sir was busy also in some other engagement. So as Tyagi sir clearly pointed, we are working with IMD from IMD and ERF team from IITM for so many years, and now it has given good result. And IMD has implemented that ERF system that was developed with the efforts of MOES institution, and now it is operationally implemented. And now slowly, gradually, we are generating the product for all sectoral applications. And this sectoral application actually it will go day by day, it will increase, and we have to venture into different sectors. For that, the science part will continue, the improvement of skill, etc. will continue. And besides that thing, our application product and the user-oriented products we will be generating. And thanks to all SAHASAP team and the entire MOS family for having this couple operational system implemented in IMD. Thank you very much.
Thank you very much. Before ending this concluding remarks, I request all the panel members to switch on their cameras so that we can have a photo. Yes.
Okay.
Thank you very much. I conclude this session here and I hand over to Mark. Yeah.
Thank you, Dr. Fani. Moving on to our next part of the this conference, that is facilitation of Dr. A.K. Sahai. I request Dr. Susmita Joseph to say a few words about Sahai, sir. Thank you, Mantri. It is actually my pleasure to introduce or to say about Sahai, sir. Dr. Atul Kumar Sahai was born on 17th March 1961 in the Siwan district of Bihar and pursued his MSc and PhD in mathematics from Allahabad University. He started his glorious career as a mathematics lecturer at Allahabad University. He joined IITM as Scientist C on 2nd July 1996 and was promoted to the post of Scientist D in July 2001, Scientist E in July 2005, Scientist F in July 2010, and Scientist G in November 2017. Dr. Atul Kumar Sahai is presently working as Scientist G and the Project Director of Monsoon Mission at IITM and leads the Extended Range Prediction Group. Dr. Sahai has expertise in climate variability and prediction of extreme weather events, operational climate services, climate change, and regional climate scenario generation for impact assessment studies based on regional climate models, and utilization of artificial intelligence and machine learning in the field of climate science. His most notable research led to the development of a dynamical ensemble prediction system for predicting the intra-seasonal oscillations of the Indian summer monsoon season. Due to the remarkable skill of the system, it has been awarded the ISO 9001-2008 standard certification in the year 2016, and it has been operationalized at India Meteorological Department. Dr. Sahai has also formulated several strategies for the application of these extended range forecasts in agriculture, hydrology, health, and disaster management. During his career at IITM, that spans 24 years and 9 months, he has taken up many additional responsibilities. During 2016 to 2021, he served as the coordinator of the India-UK Water Centre, a virtual centre under the Indo-UK collaboration through MOES. He served as the associate editor of the Journal of Earth System Science from 2014 to 2020. He was given additional charge as head Climate Research and Services, India Meteorological Department, Pune, for 2 years, that is 2017 and 2018. Dr. Sahai is also a member of the Scientific Steering Committee of the World Weather Research Program, WWRP, of WMO during 2019 to 2022. He held the chairman position of Indian Meteorological Society Pune chapter from 2014 to 2016. He was elected twice as the Vice President of IMS National Council from 2018 to 2022. Dr. Sahai has more than 140 scientific research papers in peer-reviewed journals, scientific reports, or book chapters with a cumulative impact factor of 270 and citations over 2,500 to his credit. He has guided about 15 MTech and PhD students, and 4 students are still pursuing PhD under his guidance. Considering his scientific contributions, he has been conferred with various awards like the 3rd IITM Golden Jubilee Biennial Award of IITM for his outstanding research contributions in 2016, Silver Jubilee Award of IITM for the best research paper in 2003 and 2008, Certificate of Merit Award from the Ministry of Earth Sciences, Government of India in 2008, and IMS Prize of Indian Mathematical Society for the best research paper in 1995. We heartily congratulate Dr. Sahai for his significant achievements. Thank you, sir. Play a short video.
We have got some few messages from Dr. Sahai's colleagues and associates from all around the world. So we would like to play those messages for him. So first of all, these are the slideshow.
Good evening, dear all, who have assembled here in the valedictory session of International Conference on Future Directions of Subseasonal to Seasonal Prediction over South Asia. This conference was organized
Go ahead, announce.
I request Dr. R. Krishna, Director IITM, to facilitate Dr. A.K. Sahai with the bouquet of flowers. We'll present him a memento from Institute on his fifth superannuation.
Say a few words.
Yes.
Can I?
Yes.
Yeah, sure. No problem. Nice about that service book. Very good.
I request Dr. R. Krishnan to share a few words with us on this occasion.
Yeah. So on this occasion, I just want to first of all congratulate Dr. Sahai for his enormous contributions and thank him for all the services that he has given to the institute and to the country. Right from 1996, I have known him. So we were initially together in the climate and global modeling division, and so I have known him for more than 24 years. So yes, the way he has steadily grown, it's very, very impressive. To begin with, he was working with empirical models. He was always fascinated with prediction. Prediction was his interest. And so he started with empirical models, then went into artificial neural networks, regression models, then self-organizing maps. So he was always interest was to predict monsoon precipitation extremes. And then he went on to work with the UK Met Office model, and very important papers he published. So these are all more than 15 years ago. Then later on, when he took over, we started working with the CFS model, focusing on the extended range prediction. We were initially trying to do with GCMs, this idea. So there was two GCMs. One was the UK Met Office, IITM, and then the COLA model. But we are mostly working on seasonal forecasting. Subseasonal we have not started, but there were ideas that you can do with different ensembles, initial conditions and things. But he has taken and pursued it
vehemently after that. And last 15 years, what he has done is phenomenal. The kind of research and development, building a team on the extended range prediction. So it has become a reality. And also development of various applications on forecast products, and going beyond the monsoon season, heat waves and other things also, other winter time. Now I'm very happy to see that all these are being used by different groups, and also his contribution to IMET Society, IMSP, and also National IMS is very, very impressive. And those days we used to go for tea in the morning and afternoon. Dr. Sahai, Dr. Soman was there, and he's no more. Dr. Rup Kumar, Dr. Krishna Kumar, Dr. Ingane, Dr. Milind, and myself. So we had Dr. Ernest Raj. So it was a very nice team, and a lot of science and non-scientific things. Everything was discussed, and but we used to discuss why this monsoon, it's not raining. 2005 suddenly it was monsoon. Everybody thought it would withdraw, and there was a second burst. Then we were coming back from the afternoon tea, and Sikazab was predicting it. There would be a second. So it was like a second onset. So these type of discussions were really very, very big. It was a big learning experience. And then Pansab started the this monsoon discussion forum. And so that was another experience where every week we would present. Earlier we used to go to IMD and look at the charts. Then it started at IITM. So these were all, it was a huge learning opportunity. So, and I have enjoyed Dr. Sahai's company, and we have argued, we have heated arguments and all, but that was all in good spirit. So I will miss him, but we will keep in touch, and wish you good health and your family and happiness. Please enjoy your retired life and take care of yourself, and we'll be in touch anytime. Please let us know, and it was a pleasure working with you. Thank you.
Thank you, Dr. Krishnan. We'll continue with the messages.
Good evening, dear all, who have assembled here in the valedictory session of International Conference on Future Directions of Subseasonal to Seasonal Prediction over South Asia. This conference was organized to felicitate Dr. Atul Sahai, Scientist G, who is retiring here today after 29 years of glorious service. Dr. Sahai has made his own mark in the development of a robust extended range dynamical prediction system. Many earlier speakers have spoken a lot about his scientific temperament, his achievements, his behavior, and I also endorse all of those. Apart from that, to me, he is a very caring mentor. He is out and out team man. As a team leader, he takes decision and he owns it. A very remarkable quality. I knew Dr. Sahai right from beginning of his career, but became very close of each other once India was organizing SASCOF. IMD and IITM both were co-organizers of those events. I was the coordinator of SASCOP, and he was nominated from the IITM side to help in all logistic arrangements and whatever need IMD require from IITM side. He not only guided me at every step, but rather he was willingly helping me whenever I approached him, even in odd hours. During those events, I came to know about his nature, about his behavior, about his other human qualities. And from 2017 to 2019, he was head of the India Meteorological Department, Shivajinagar, Pune, and I was the head of climate division. I was closely working under him. That time, how he was helping, how he was guiding his juniors, how he was giving directions, how he was, his caliber towards administration was, I was noticing all those things. I was very impressed. And his human nature, I would quote one example. Before coming to IMD, he was working in IITM and I was in IMD. You know that IITM and IMD is having one cooperative credit society from where we borrow loan when we need, if we are member. Once he was standing there and I was passing through, I asked him, sir, you are here, are you depositing some money or you are asking for loan? Then he was laughing and he told, no, today I have come to ask some loan. Then I told, sir, you don't require any loan. Then he told, no, sir, today my maid, she is requiring some money and I'm not having that much amount, so I have come here to borrow loan for her. You see, I was so impressed. Such a big officer, he is asking loan for her maid. He is asking loan for his maid. This makes him apart. This makes him very, you can understand how he is. And only a line from Tulsidas I will mention about him. मुखिया मुख सो चाहिए, खान पान कहूँ एक, पालई पोसई सकल अंग, तुलसी सहित विवेक. I will explain in Hindi, in English. मुखिया मुख सो चाहिए. The head of the family or head of the institution should be like the mouth. मुखिया मुख सो चाहिए, खान पान कहूँ एक. From mouth only we eat. पालई पोसई सकल अंग, तुलसी सहित विवेक. Although we eat only from mouth, but all parts of the body are developed. So our head of the family should be like that. He should not only take care of himself, rather he should take care of those who are associated with him, those who are working along with him. And Dr. Sahai is like that. On this occasion, I wish him a very happy, peaceful, and successful retired life for Dr. Sahai. Thank you.
Hi, Dr. Sahai. How are you? Dr. Sahai and I go a long way back. May 1994, probably when we met first. He's a great mathematician and a great scientist, a go-getter, and I'm really jealous of this excellent product that he's generated, the extended range forecast, which he's designed. The whole concept is started with statistical prediction and then modeling and then merging them together in different combinations. Ultimately, a fabulous product that has been operationalized, and I'm very proud of his association all these years. He's been always motivating us in a very, very excellent ways. Of course, we have collaborated. There are at least 3 to 4 papers we wrote together. The last one being the non-linearities in El Niños and many other science topics. And interestingly, recently we have done one application of his product. So he has been a great addition not only to the institute and ministry, but his contribution to the country, as Subimal mentioned yesterday. It's a great gift that the country is in debt to him for this nice product, and I'm sure he will continue his work, probably in the ministry itself in some position, or definitely some university or institute will lap him up. And so I don't have anything special at this stage as far as work is concerned. I'm sure he will continue and we'll all work together. And just I hope he will get time to do more exercise, and he's a yoga person. I guess he will continue doing the same things. All the best, Sahai. Keep in touch. Bye.
Myself, Dr. Malsal Murli Nageswara, working as a UCAR visiting scientist at Nova NCEP EMC, College Park, USA under Dr. Vijay Talpragada. Today I am delegated to share my feelings on our respected Dr. A.K. Sahai sir. Since I have joined in his group at IITM Pune as a project scientist C, and I observed that Dr. A.K. Sahai is very optimistic person with an empathetic attitude and also an extraordinary ability of maintaining the team spirit. I am lucky to have an opportunity to work under his guidance, and he is the incredibly supportive and helped me a lot. And words can neither quantify or not qualify how valuable his guidance and advice to me in shaping my professional career. I got an opportunity to work with CPC and EMC at Nova NCEP under Dr. Vasila and Dr. Vijay because of his support and guidance. Dr. Sahai truly made my life have an impact by the continuously encouraging me to look at a bright side of my life. I will always strive to live up to your example. Is inspiration to everyone, and congratulations on this monumental achievement. I sincerely like to express my profound gratitude for his invaluable experience I have gained from you and also your impeccable service. I hope you to encourage us the same way in the future. My hearty congratulations to you, sir, on next milestone in your life journey. I would also like to inform you that Dr. Vasila and Dr. Vijay also conveyed their congratulations to you, sir, for your achievements and services to our meteorological scientific community, and best wishes to your future adventures. Finally, I am thank you very much to the organizing committee for giving this opportunity.
Good morning and good afternoon to all of you. I am Dr. D.R. Patnaik, presently working as Head of NWP Division in IMD New Delhi. I started my career in atmospheric science from Pune, first as MTech degree in Pune University, then joined as research scholar in 1996 in IITM. During that period, there was also a search school conducted by IITM, and I met Dr. A.K. Sahai for the first time during that search school. And also there was one advertisement for the post of scientist C by IITM, and since Dr. Sahai was having the PhD degree in applied mathematics, I suggested him to apply for the post and he will get it, and finally he was also selected for the scientist C and posted in the same division where I was doing my PhD work, that global modeling division, and we continued our work and association with him after I shifted to IMD also. And basically on all discipline, monsoon research, cyclogenesis, extreme weather, climate change, we have worked together on various disciplines and published many papers. And finally, the contribution of Dr. Sahai in implementation of this operational extended forecast system which is great, and with the efforts of Ministry of Earth Science and all other departments, we could implement in IMD the operational coupled modeling system for extended forecast. And Dr. Sahai and his entire group, I have worked together from IMD side, and we have implemented that thing, and that is giving good result. Besides our scientific association, IMS activity also we are involved together. I am the secretary of Med Society, and he also the vice president, and we have arranged many symposium conferences. The TopMed 2018 in Banaras, that was a very successful event, and scientific committee were also there, and it was a good thing. And now Dr. Sahai retiring this March 2021, and though government job he is retiring, but his scientific contribution and association will continue, and we will work together. And I wish him all the best for his future assignment, and thank you very much to all of you.
Hi everybody, this is J.R. Kulkarni, retired scientist from IITM.
I had a very long association with Dr. Sai. A global climate and global modeling division was formed under me in 1994. We had a very small group, very handful of people working in this division. Initially, we concentrated on predicting the long-range monsoon rainfall using the global models, using persistent SSTs, as we had no ocean model. Dr. Sai joined our group and he expanded activities to this simulation studies and intra-seasonal variability of the monsoon. Dr. Sai also initiated the studies using the artificial neural network for forecasting the monsoon rainfall over India. She developed expertise in numerical weather prediction of the monsoon, intra-seasonal variability, and the extended range forecasting of the monsoon. He contributed to meteorology through his publications, seminars, and presentations of paper in the conferences and workshops. As a chairman of Indian Meteorological Society Pune chapter, that is IMSP, he was very instrumental in making the IMSP as a forefront in India. His guidance in conducting the annual monsoon workshop, teachers training program were very useful in making those programs a very successful one. With this, I wish Dr. Sai a healthy, wealthy, and peaceful retired life. Thank you very much.
Namaskar, sir. I'm Kanhacharan Patnaik. I worked with you on my MTech dissertation in 2005-06. So it was my first experience to introduce to one of the best research institute in India. So I was quite nervous at the first time to come to such a big place, coming from a small town or small village. So you made me comfortable through your simplicity and knowledge. Now I'm a postdoc in University of Leeds, United Kingdom. So I think by your guidance and your support, I reached here. I could not have, without your guidance, I could not have reached here. So thank you for all your support and encouragement. I wish you a very happy and healthy retirement life. Thank you, sir.
The National Center for Medium Range Weather Forecast started medium range weather forecast based agrometeorological advisory service in the year 1991. Encouraged by farmers' feedback and considering the growing demand for farmers to provide extended range weather forecast at agroclimatic zone scale and generate extended range forecast based agromet bulletin, it was decided to launch a pilot project at the selected 16 agroclimatic zones of the country. It was at the initiative of the Ministry of Agriculture. The project was granted to Indian Institute of Technology, New Delhi, under leadership of Professor U.C. Mohanty and Professor S.K. Dash. And at this point in time, while IIT Delhi started working and later producing extended range forecast, concurrently we were also looking forward towards other agencies such as the National Center for Medium Range Weather Forecast, IMD, and Indian Institute of Tropical Meteorology to do similar efforts. And at that point in time, my association with Dr. Sahai was seeded and thickened with time to cater to the needs of the farmers. Dr. Sahai was always forthcoming to meet the expectations of users, both intermediaries as well as end users, including farmers. His professional honesty and willingness to support Agromet Advisory Service has culminated into refining extended range forecast over the time, and ultimately an operational extended range forecast system have been put in place in India. As we know that India's Agromet Advisory System is very unique in many ways, and extended range weather forecast system became a vital component of this service over the time, and farmers are really making use of this information in their decision making towards enhancing the farm production. So therefore, contributing to this very useful service, my salutes to Dr. Sahai for contributing made towards enhancing the value of Agromet services and helping the farmers in particular. My best wishes to Dr. Sahai.
Hello everyone, and my special hello to Dr. Sahai, my worthy colleague for last few years, a person who has not been towering tall in terms of his scientific achievements, but in terms of his personal nature, I would say. Dr. Sahai is something beyond words actually, and if I have to define him as a personality, I would say that he's very calm, very matured, unassumingly intelligent, and a worthy colleague that everybody would like to work with. I think all of the people who have worked with him at IITM may actually connect with these statements of mine actually. Though while being in ministry till about 2015 December, my work with him was more from remote locations. But whenever we were together in person, the kind of vibes he gives, they were phenomenal actually. So I won't call it retirement for him, knowing him so well. In any case, I don't believe in retirements at all. I personally feel that it is the second inning of him, and he will do as equally good, in this second inning of him. Actually, rather it is going to be a kind of holiday for him, wherein he plans things for himself, whether it is work, whether it is personal space, or any kind of adventure he wants to undertake in future. Actually, I really wish him all the best in his all future endeavors, and would like to connect with him throughout my life for being what kind of best friend he has been till now. Thank you so much.
Hello, Sahai sir. Heartily congratulations on your retirement. You have an outstanding career with lots of achievements. It's a great privilege and honor for me that I had a chance to work under your guidance and leadership for 7 long years at IITM during my master's and doctoral research. And I believe that this experience have been most rewarding. You have always been very, very supportive and motivated me how to excel in life. Thank you so much for your guidance, support, and encouragement throughout the years. Your scientific contribution to monsoon research, especially to seasonal to subseasonal prediction, is immense. And I believe your leadership is exceptional. I also believe that your legacy will benefit the scientific community for many more decades ahead. I'm sure that you will remain active in research even after this formal retirement. I wish you all the best and wish you joyful and healthy retired life. Thank you. these were few wonderful messages from Dr. Sahai sir's colleague. So, of course, the dedicated work Sahai sir has done for the institute and for the science wouldn't been possible without family support. And today we are glad that Madam Sahai can join us. So I request Dr. Sushmita to present bouquet of flowers to Madam. Thank you so much, ma'am. Now I request if any of the participants have some words to share with us. Please, you can raise your hand. I request our support to unmute the mics. Dr. Andrew, you would like to say something?
Thank you very much.
Okay.
Thank you very much. Yes, I just wanted Dr. Sahai to add my hearty congratulations to you on your retirement, and really to congratulate you on the incredible legacy and the team that I've seen that you've built at IITM and IMD on dynamical extended range prediction in India. It's really been incredible to see that, and we've interacted. Thank you. I've really enjoyed interacting with you over many years. There's really been huge advances in the using dynamical models and creating a world-class operational ensemble prediction system for S2S in India and under your leadership. And we're really looking forward to have that in the S2S database soon. So I wish you the very best of health and happiness in this next chapter of your life. Thanks again for all your valuable contributions to S2S, including as our liaison to the WWRP steering committee. I'm sure and I truly hope we'll continue to collaborate. Thank you.
Thank you, Dr. Andrew. If there is no one else to speak from forum, I request our scientist G and project director Monsoon Mission. Okay. Okay.
Yeah,
Hello?
just two lines.
Yes, sir.
Because very strange situation, Sahaji. We are not able to, shake hand or, try to hug each other. I did not do PhD under Sahaji, but, I just like to share two things. So it's very personal, but I will tell. See, there was an advertisement in IITM, okay? And we joined, we all joined, not in a very high positions. So I was wondering whether to apply or not. So Sahaji was our friend, philosopher and guide. After that, he has become friend, philosopher, guide of the whole world. But he first became our friend, philosopher, guide, as Krishnan told. So Sahaji told, you go and apply. Then I told, no, because, there were many other suggestions. People were telling, don't apply this post, etc., etc. He told, you just close your eyes and apply. Okay. He forced me. He motivated me so much. Then I applied, just because of him. And then I became scientist C. It was open interview. I got selected. So my hats off to Sahaji. Number two, you see, now when we publish paper in JGR or any journal, they say, where is the data? We give the source. Okay. why this culture has started? Because they understood that the results are not reproducible. But when this culture was not even there, Sahajist, everything was open. All his directory, it is CH mode 777. This culture, he has started. He has started. And I think, you know, nowadays we see in Facebook, accept challenge. Let us promise today, accept this challenge. What Sahaji has done in these 26 years, I will tell all those who are present today, those students who will become scientists tomorrow, everybody, take this challenge, take the legacy forward. Take the legacy forward, that will be the best, befitting, you know, our honor and respect to Sahaji. Sahaji and Bhabiji, namaste. Wish you all the best, happiness, great health, great enjoyment. Keep guiding, and God bless you. Thank you.
Thank you, sir. Thank you so much. Okay. So I now request Dr. Surya Chandra Rao, Project Director, Monsoon Mission, to say a few words for Sahai.
Okay, good evening, everyone. Dr. Sahai, Bhaviji, and Krishna. So I first met Sahai in 1994. There used to be DST sex schools. That is the first time I got a chance to meet him. And first thing I noticed is that he is the most jovial person in the whole group. He used to crack many jokes, but of course I could not understand most of them because I don't know much of Hindi that time. So that is the first introduction to Sahai. And then again, I came to this in 2008. So since then, actually I am following him. First, he was the one who was doing the seasonal prediction work using EM model. Then I followed his footsteps and started coupled modeling in seasonal prediction. Then he was also taking care of HPC. Yeah, first teraflops HPC was established in this institute with 7 teraflops. Then I became partner in the crime with him. Then moved to, now you know all that we have a 4 teraflops computing system. Not only in the science, I was following him in other aspects also. In the campus maintenance and advisory committee. He was the first chairman as far as I remember. I don't know before that he was there. So yeah. So then I became the second co-chair with Dr. Baig. So that is how I've been following him all throughout my career in IITM. So not only in scientific but also personally also. He started doing yoga. There also I followed him. Maybe after he started 2 years after that I started. So it was like more like a brotherly relationship than anything else. Of course, in his sibling we also fought many times in different aspects, but our interactions are always very good interactions. I really wish that he should be continuing in IITM for several more years so that I can keep following him and also keep having arguments. So I really miss if he's not continuing here. So we are making all attempts to keep him here. So I don't wish him a happy retirement life, but continuing research. This is what.
I request Dr. Sahai to say a few words.
Respected Dr. Krishnan, Surya, Partha, Tyagi Sahab, Watson, and other those who are present in this valedictory function. And friends, colleagues from IITM, IMD, and also students. First of all, I would like to thank IITM, IMD, and WMO S2S project to organize this webinar in which leading scientists working on subseasonal-to-seasonal prediction have presented their views on how these predictions could be improved and how it could be more beneficial for society. Coming to my retirement, I would like all my year who have contributed in some way or other and are responsible in shaping my scientific career and stayed with some difficult, or you can say very awkward situations also. I did my MSc from Allahabad University in the applied mathematics background, and I studied fluid dynamics, magnetohydrodynamics, plasma mechanics, quantum mechanics, theory of relativity, etc. In addition to mathematical modeling, group theory, ring theory, number theory, linear and complex algebra, topology, etc. I did my PhD with renowned mathematician like Professor H.C. Khare, and my topic of PhD was stability of magnetohydrodynamic fluid through porous medium. But all these were only theoretical. Before joining IITM at Surya and Partha and many people mentioned, I attended 2 circuit schools here in 94 and 95, which were immensely beneficial for me. And I would like to thank Professor R.N. Keshamurthy, who has provided me an opportunity to serve in IITM. He actually selected me here, but before I joined, he has retired from IITM. During my PhD, I did only theoretical work, and in each paper, in the summary, we were writing that this study will find application in atmospheric science, ocean science, etc. That's all. But the real challenge was to apply some of my experiences in monsoon understanding. I first chose to go for IMD advanced training, and I thank Dr. Kamara, Dr. Pant for advising me for this, and Dr. Satyan to kindly permit me to go for training with caution, because that time he told that I will be the first person going for training after doing PhD. So that was his remark. But I must say that advanced mid training has given me ample opportunity to learn all aspects of meteorology very comprehensively. Back at IITM, I started my work with late Dr. M.K. Suman, who was the best mentor and friend. Without his guidance, I could have not achieved with what I did. I also got some very good colleagues and seniors like Dr. Rup Kumar, Dr. R.H. Kripalani, Dr. J.R. Kulkarni, and most importantly, ex-director led Dr. G.V. Pant, who always encouraging and ready to help and share me with any data and any analysis techniques like that. I was also fortunate that Dr. Krishnan has mentioned that Dr. Krishnan, Hingne, Dr. Krishna Kumar, Dr. Majumdar, Sable, all we were going together for having a team and discussing many things there. So I also this time many more IITM and from IMD, Dr. Mali, Dr. Chattopadhyay, Dr. A.K. Srivastava, Dr. Pai, Dr. Datta, Dr. Pulagwar Chakuta, Dr. Jamadar, and many more colleagues at IMD and IIT Pune. I thank them with whom I work. So actually, one thing was when I did my advanced mid training, that had saved my career for monsoon, because I was only doing theoretical things before that. And the second thing was when I went to Federal University of Parana to work with Elise Green. There actually in India, the comparison was that their internet was totally fast and free, and so many things we could learn there. And actually many things I learned there, still I am exploring here, and many things are still not explored. So I'm thankful to Elise and team there. I'm also thankful to all my directors, Professor B.N. Goswami, Dr. M. Rajivan, and Professor Ravi Nandanjaya, who have given me friendly atmosphere and free hand to work. Also, secretaries Professor Goyal, Professor Shailesh Nayak, and DGs Dr. Ajit Tyagi, Dr. Rathod, Dr. K.J. Ramesh, Dr. Mahapatra, for giving me opportunity to work with them. I am especially thankful to Dr. Rajivan and Dr. K.J. Ramesh for providing me opportunity to work as the head climate research and services IMD Pune. This was totally a different experience, and we could achieve many things when I was there for 2 years. I am also very fortunate to have interaction, discussion, and encouragements from let Sikka Sahab, let TNK, Professor J. Shukla, Professor Sulochana Gadgil, Professor S.L. Srivastava of Allahabad University, Professor P.C. Pandey, Professor S.K. Dubey, Professor J. Srinivasan, Professor J.S. Bhatt, Professor D. Sengupta, Professor O.P. Sharma, Professor S.K. Das, Professor Mohanty, Professor Devra, Dr. Salvekar, Professor Mohan Kumar, Dr. Ajit Tyagi, Dr. Rathod, Dr. Ramesh, Dr. Akhilesh Gupta, Dr. N. Rajagopal, Dr. Ashish Mitra, Dr. M. Ravichandran, Professor R. Bhatla, Professor Mal, Professor Shubmal Ghosh, Professor Subhankar Karmakar, Professor Bimal Misra, Professor Venugopal, Professor Pankaj Kumar, and many more who has name I am not mentioning here. So coming to my scientific contribution, I started first working on artificial neural networks. Dr. Kishan told that I was fascinated for monsoon prediction. There is a background behind that. And I will say to everyone that whenever you have something in your life that someone is making you to stop somewhere, or there is some obstacle, then you have to come up with more vigor and more strength and confidence. So when I was doing my advancement training, and there was we have to do some project, I thought I will do something on monsoon prediction. I went to meet that time I am the one person who was doing that. Now he is not there, retired. So I sat 3 hours outside his room. He even didn't meet. And then through his PA, he sent 2 papers that gave him to study. And this. I thought, okay, so I will do this monsoon prediction. So if by this one has to become so big that 3 hours means I was sitting there. So means sometimes these things are very good in your favor. If someone says that yes, so that is like that. So after this, then in 2003, Dr. Krishnan told I was responsible for UKMet Office model, so artificial neural network, UKMet Office model, then PRESIS model. Dr. Rup Kumar told in the morning that the first scenario we have generated a regional climate change scenario with Dr. Rup Kumar, and actually these scenarios have been used widely for impact assessments and in various sectors, and this has paved the way for establishment of CCCR. So then finally in 2006 and 7, I started working with my student Dr. Rajiv Chattopadhyay on subseasonal variability and prediction using neural networks and self-organizing maps and this. So, and simultaneously after a few years, in 2011, Monsoon Mission project was launched, and we started couple models. And then my group was established with Dr. Sandeep Patnaik, Dr. Vilas, Dr. Rajiv, Dr. Sushmita, Dr. Fani, Somyendu Dey, Mr. Raju Mandal, Abhijit, Sharmila Sur, Navanita, Manpreet, Pratibha, Mahesh, and so all are there. So they are always and will be always with me in every situation. So with collaboration of Dr. Mali, Dr. N. Chattopadhyay, Dr. Pai, Dr. Patnaik, Dr. Somnath Datta, Dr. Kulak, Dr. Sajid, Khan, Dr. Ratri, Dr. K.K. Singh, Dr. Sanjeev Bandyopadhyay of Calcutta, and others, the extended range forecast have found applications in various sectors, be in agriculture, hydrology, health, and disaster management. I thank all my collaborators for making ERP a great success from science to the service of society. I would like to say, like I told you, that sometimes obstacle and criticism will come, but we have to face it and come with more strength and determination and focus in this. At the end, I would like to thank my two, we can say, hands, Dr. Surchandra and Dr. Parsathi Mukhopadhyay. We actually together did and fought many things and is still fighting on many scientific and other issues. But we have taken monsoon mission program to some extent in this state. So I will miss if I will retire. So in the end, I should say that I have very cordial relations with all administrative Group 3 and Group 4 employees, not only at IITM but also at IMD, and they have given me full support. For that, I thank them. Today may be the last day as government employee at IITM, but I will always be there associated with IITM, IMD, and MOS. Thank you all. Thanks.
Thank you, sir. On the behalf of organizing committee, I request Dr. Surya to present memento to Sahai. Sahai, sir. And of course, from the Air Force family also.
Thank you, sir.
Thank you everyone for attending this session, and thank you for patiently listening to all the talks and being with us for last 3 days. We thank you once again for each and every participant, and we now go offline. Thank you so much.
Thank you.
you